Hello guys, welcome to another grand interesting video on our behavior channel. In this today's video we are going to understand about the statistical graphs used in stay time. So in the previous video 6, we have already seen these 4 types of graphs which we use in stay time, and in this video we are going to analyze what are the stay time by type, stay time by hour by type, and item trace Gantt chart graphs. So we are going to find out the graphs into the dashboards and we are going to understand how to use them. So in this today's video we are going to complete the stay time statistical graphs for our video. So if you haven't liked, shared and subscribed to our channel yet, please do like and share and subscribe to our channel. So without wasting much of the time, let us begin. So in today's video what we are going to learn is we are going to bring in the first graph into the place, which is stay time by type. So I'll just reset the model, and what I'm going to do is I'm just going to rearrange this graph in our dashboard window. We have brought in the stay time by type graph. So if you have seen our videos from video 1 till video 6, you might be knowing the processor functions we are using here and the buffers we are using. We, in order to keep the similarity or to do apple to apple comparison, we have kept the model as same and we are using different graphs onto the same model. So what we are doing is the output from this Q1, Q2 and Q3 we have assigned type 1 on the Q1, type 2 on Q2 and type 3 on Q3, and then it comes to these 3 Qs and then it gets combined to a single processor and it comes out from the Q7. So this is a whole high level information for a model. Now what we are going to analyze in this thing is we are going to find out what is the stay time for by label type. So we are finding out what was the stay time for my type 1 item, for type 2 and type 3. So that is what we are going to identify using the stay time by type graph. So when you click on this graph, you are able to see the properties window on the right side. We have 2 options here: entrance object, exit object. Then we have type label here, which is set to type. We are not going to change because our label is also type, whereas this is also our number. We are going to keep this as same, and the time units in which we are going to get the graph, we are going to put it in seconds. Now what we are going to analyze, so we are going to analyze that what are the stay times for my type 2 part. So what I'm going to do is I'm going to select entrance object as Q5 and I'm going to select a exit object as Q7, and whenever I'm going to reset and run this model, I'll just show you. So what I am going to get in a run duration of say approximately 3 minutes, what I'm going to get is I'm going to get this average stay time, okay, average stay time for item type 2, okay, between Q5 and Q7. What was that is what I'm going to get. So if I want to analyze say a stay time for item type 1, item type 2, then what I need to do is I need to include Q6 also, I need to include Q4 also. So when I am going to do that, I'm going to reset and run the model. You could see, I would be able to see item type 1 has an average stay time of 63 seconds, this is 73 seconds and this is 41 seconds for item type 3. We have considered time units in seconds, so this is what we see is it in seconds. So what you came to know from the stay time by type, entrance object, exit object is that it is going to tell us that between these Qs and this Q, if I am going to have these item types, what is its average stay time. So if you remove that, as we saw in first example where we just selected this Q5, we are not going to get the stay time data for item type 1 and item type 3, okay. And now what we will do is we'll just copy, we'll just paste this graph here. It is the same graph, and we are going to delete this buffers and we are just going to take a source, okay, a single source, and we are going to run it. So now what you see, this graph is to find out the stay time between these 3 buffers and this buffer, Now this stay time is basically to find out the stay time from the source till my Q7. So you could see now the difference for item type is 87 seconds here, 75 seconds here, and 95 seconds for item type 3. So this is the greatest capability of this graph of stay time, as we have entrance objects where we can put in, and we have exit objects which we could assign, and we could get the data set between two entities. So this is the purpose of the stay time by type, where we are going to get the details of average stay time based on the item type. Okay, and now we are going to understand what is stay time by hour by type. So we'll just delete this. Okay, we'll just keep one of the graph of ours, and we are going to drag in this graph which is stay time by hour. So we'll just keep this as per minute, as our total run time is only 3 minutes. And similarly we are going to select the entrance objects as these 3 buffers, and then exit item we will be selecting as this queue. Let us reset and let us run, and what you're going to get it is visible here in this way. So if you could look at, this was my every minute stay time. So if you could look at, the item type 2 is having the highest stay time, okay, and the lowest stay time is for item type 3, which you could clearly identify by this line chart. This is what is the power for line chart. By visualization itself, you can directly find out the interference of the graph. You can directly do the analysis, and you can find out that we need to work on item type 2, and there are no worries for our item type 3. So you could also look at in the simulation model that our buffer is filled, Q5 is filled than our Q6, and the lowest filled buffer is Q4, that is item type 3. So this is a very powerful tool, powerful graphs we are able to see in the dashboards, okay, using the statistics. So this is our another graph, that is stay time by hour by type. So we have selected an interval of 1 minute. So every minute we are going to see what is the change in the stay time. So you could see every minute I'm having a graph which is in an increasing trend for stay time. So this is the another graph which we have completed in our session, and the last graph which is pending in the stay time area is item trace Gantt chart. So I'll just put in here, okay, I'll just reset this, and we'll now understand this item trace Gantt chart. So the Gantt chart itself, we know it is nothing but it comes in a graph, and it gives us the interval of the times where it has been spending its time. So what we are going to do, the first thing we'll do is we'll just take this Q5 and Q7, okay, the duration we have kept it in seconds, and what we are going to do is we're just going to reset and we're going to run. What you saw, I'll just reset and run again slowly. Just look at this, see what is happening. So you are getting the graph being populated for every part. Can you just imagine? So whatever part we are going to have in this buffer in between Q5 and Q7, you are going to have analysis for it. So you are going to have the stay time details for that every part. So the first part, okay, it came in the buffer and it directly went into the processor, as we did not had any stacked up or something. So the duration it spent in the processor was 10 seconds, and that is our cycle time, okay, that is our cycle time, so it shows here. Now the next part waited for 7 seconds, and then it was processed for 10 seconds in this processor, okay. So this is how we are going to get the detail for item trace Gantt. So when you need to find out the details of stay time for every part, okay, between one entity to another entity, you can use this item trace Gantt, okay. You could directly get the part details stay time. So now if you could look at the third part, okay, actually waited for 34 seconds and then it got processed for 10 seconds on the processor. So you are seeing how exponentially it is changing the stay time, how greatly it is getting varied. So that's what you will also able to see in this line graph. So how greatly it is changing. See, in even 3 minutes it just popped up to 140 seconds, and that is what you are going to get in this. So when you look at the 60th part has just arrived, so it is just waited for 2 seconds. But if you go down, okay, the moment you are going to go down, you are going to observe, see, 142 seconds this 7th part was waited. I don't know now how much this will be waiting, and now you could have an idea that what is your system. So now you can plan your system, make modifications in your system based on the analysis you are going to do from the graphs which are going to show you. So now you know that the bottleneck thing is our item type 2, which you need to work on because that buffer is getting filled. So we need to work on to find out how this buffer cannot be highly utilized, or say we have a minimum stay time on the buffers. So this graphs directly give you an idea what is the bottleneck, how much you need to reduce and all those stuffs. So it is very important for a simulation engineer in order to analyze the data and to pick up a right graph for a right type of inference you need to take out, and to do a right analysis using that right graph. So it is very important to have a great information and idea on using these statistical graphs and analyzing it, because that is basically the heart, or you say a brain or output of a simulation study you're going to do. So it is very important for you to know what graph is used for what and where we can use it. So if you haven't liked our video, please do like our videos. We are having a lot of views on our videos, but nobody is liking. No, I don't know what is the issue. If you have any queries, please do comment. I want likes equal to views, okay guys? So if you are watching, please give a like. Do comment in the comment section whatever you feel. If you love it, just comment I love the video, just do that. But please do not just watch and leave. Do like, do comment, and do share it, okay? If you haven't subscribed to our video, please do subscribe to our video. Do share our channel with your friends and colleagues so that we spread this knowledge of simulation across them. If you have any queries, you can reach out to us from our website behaviorchannel.com, or you can send us via email. We already have a website created just for your convenience. You can reach out, you can watch the stuffs, you can purchase premium content. We are going to bring in a new video series on it, so do get registered, do purchase a subscription, and we will be having great videos brought there for you. So till then, we are going to get connected in the next video. So this is our video 7. Let us meet in the next video 8, where we will be analyzing the next set of graphs, that is state graphs, okay? And we will understanding this importance of these 3 graphs in that video. So stay tuned with us. Let us meet in another interesting video 8 on our BAV channel. Do like, do comment this section, and we really love your comments. So till then, stay safe, stay simulating.